evening, everyone. My name is Prudence, and I will be your host tonight. I would like to welcome members of Walter's Wildlife Discussions. So before we get to today's talk, I'll briefly share what Walter's Wildlife Discussion is about. Walter started the Walter Wildlife Discussion in March 2021 by creating a YouTube channel, a Facebook page, and profiles on various other online platforms. In January 2023, Walter created a WhatsApp group. He initiated the informative conservation WhatsApp group with the aim of educating individuals about the vital significance of wildlife conservation. If anyone is interested in joining the group, please follow the link that will be provided in the chat. Today's talk, titled The Use of GIS in Ecological Monitoring, will be presented by Mr. Kudzai Mpakairi. Mr. Kudzai Mpakairi is a seasoned environmental scientist holding a Bachelor of Science degree from the University of Zimbabwe and a Master of Science degree from the University of the Western Cape. Stands as a distinguished authority in the fields of environmental assessment, conservation, remote sensing, and geographic information systems, also known as GIS. His recent endeavors encompass the vigilant monitoring of groundwater ecosystems in close collaboration with the SATIC Groundwater Management Institute. Kudzai has forged impactful partnerships with prestigious organizations such as Vision RI, UNDP, AWF, WWF, and the Kazakh Transfrontier Conservation Area. Armed with profound expertise in GIS and remote sensing, he boasts an impressive portfolio of research contributions comprising of numerous publications in Scopus Index journals. His research endeavors traverse diverse multidisciplinary domains, including climate change, natural resource management, and comprehensive land use assessments. So Mr. Kudzai, over to you. You can share your screen and start your presentation.
Thanks, Prudence, for the wonderful remarks. So, welcome, guys. I'm happy to be having this talk with you guys today, and I know the wonderful work that Walter has been doing, and how he set up the WhatsApp group and all the conversations that go on in that group. I haven't been an active participant. I'll probably join the group as well, but I am happy to introduce and just talk a little bit about how GIS can be helpful in conservation and environmental monitoring. The title is a bit different, but I hope this one is more captivating and will keep everyone alive until the end of my talk, right? So my name is Kudzai, as Prudence said. I'm from the School of Wildlife Conservation at the African Leadership University. I will be talking about from field cells to conservation, Earth observation for conservation and environmental monitoring. I want this talk to be more of a discussion, as much as I will lead the talk, but you're free to interject. I won't be able to see your if you raise your hand or anything, or your reactions, but please feel free to send the reactions so that I can see them. I want this to be as impactful and enlightening as it can. So please, like I said, I want it to be interactive. So kindly go to that link and type in you can kindly go to that link and try and type in that password 2602-3571. We were just gonna have a small quiz before we start. I mean, to allow the other guys who are still joining to join in, and probably just to bring in that competitiveness that is probably in one or two people around here. So let's get this started. I'm just gonna give us probably a minute or so for people to to log in and to visit the link. You can just simply type menti.com, and we're gonna have a quick quiz. I don't know who remembers quiz from back in high school or elementary school, but it was something that I did enjoy, and I occasionally participated in these things. So yeah, let's see how you guys will do on this one. So these are general questions. Some of them are GIS, some of them are just ordinary questions that out there. So your general knowledge would definitely be important to these responses. And yeah, and then there are also GIS questions that will also be there. So I'm just gonna start in the next minute or so. So go on the website, visit the website, just type menti.com, and then when it requests, please type in that that code. Okay. So we are waiting for the players. So the code is right there at the top, 26023571. So you just go to menti.com and then you enter the code. So once we are probably three, I mean, we can't compete with one person in there. So maybe if we have two or three people, then we can get started. Yeah. And for all the guys who are joining in, we're gonna have a quick quiz before we start. So just visit menti.com and then enter that code, or simply feel free to scan the QR code that is being shown on your computers. And the uh, bottom on my side is the left corner, so I'm not so sure, but it's on the bottom. It's going to be on the right or the left for you guys. Okay, so waiting for more people to join. Um, Probably if you can have three or four people, I think it becomes more interesting, right? Because already we have a number one and a number two, so probably if we can have three more people to join in and then join in on the quiz, then I think it'll be more interesting and more competitive. Okay, so we can start now. Okay, so the first question that we have for the day is uh, one quick rule that you should remember is trying to answer as fast as possible. What does GIS stand for? Right? So what does GIS stand for? You have 10 seconds to go on. Oh, good. Everyone was there. So everyone, oh, Geographic Information Systems. Oh, this is very funny. But it gave the wrong answer when it's supposed to be the correct answer. But don't worry, let's look at that again. Okay, question number two. Question number two. Again, please answer as fast as you can. Which country officially has the best jollof rice? Between Senegal, Nigeria, Ghana, and Cameroon, which country officially has the best jollof rice? Oh, good. Everyone has voted. What is the answer? The answer is, oh, now we have three players. Okay, player three can join in from where we are. Um, what are the two general data formats that are used in GIS? What are the two general data formats that are used in GIS? Now, for the first person has answered, the second is about to answer, and the third, ah, good, everyone has voted. Someone said points and lines, with someone who said victims, rasters. That person was correct, but we'll see. We'll see at the end. So I did a little bit of switching of the questions, not by fault. I think something happened when I was creating this, but yeah, definitely. GIS is basically the two data formats that are used when we're talking about GIS is vector and raster, not points and lines, but vector and raster. So this person who said vector and raster is the correct answer. Okay. Now, again, please answer as fast as you can to get more points. In what language is the phrase Hakuna Matata? In what language is the phrase Hakuna Matata? Is it Swahili, Yoruba, or Dutch? Right. Good. Let's see. Sorry, I forgot to click the question that shows the answer. I will do that at the end when we see the polls. And then the last question is, I think the last two questions. Um, sorry. Something happened there, but unfortunately, I won't be able to go back because of time constraints. I would have loved it to really show and discuss more about this quiz. But anyway, it did not come out as much as I wanted, but I hope people had a little bit of fun with the quiz. Anyway, let's start with the presentation. So, like I said earlier on, today I will be talking about um, GIS or Earth observation and how it can be used in environmental monitoring and conservation. And I have a famous quote that I like um, that was said by Kudzai, one of the fathers of GIS, or who pushed the use of GIS from back then. He said that almost everything that happens somewhere, and knowing where something happens can be critically important. So this is the fundamental principle that guides the use of GIS today, because it is important to know where something happens because location is very important. For those of you who did probably a course in GIS or have done a little bit of history in GIS, you would realize that it all started from a well that was contaminated, and then there was cholera, and then it went on to trying to understand why people are infected and so on and so forth from the well, which was infected. And from there, that's where the discipline grew from. And this is at the 19s where all this started. And today we've now understood, or we're still trying to understand how we can integrate GIS to make everything better and we can understand phenomena on Earth. And one key area that we use GIS in is in conservation. And I'm sure most of you guys here are conservationists or work in conservation or have a little background in conservation. And parting words before the end of the presentation is that always remember that everything happens and it happens somewhere. Knowing where something happens can be critically important. You should at least forget everything else that I talk about today, but at least that quote should stick and probably guide you in knowing why GIS is important, because it is always important to know where something happens. So geographic information, what is geographic information? So we have two types of um, uh, commonly referred terms like GIS, remote sensing, um, and so forth. And when we talk about geographic information, what differentiates it from information? Geographic information is different from information because we add the geography before the information. If we were to ask about the definition of information, it's just trying to make sense out of data. So meaning that when we have geographic information, we have data that has a location, and we are trying to make sense out of that data that is location, right? So geographic information is information about places on the Earth's surface. The moment we put an X and Y to any entity that exists on Earth, it becomes geographic because it is placed or it is rooted in something. So that information is scarce and not easily available in most cases when you want it, But of course, there are ways and methods of trying to get that information. So, for example, this is an AI-generated map that shows the topography of an area. You can see the rivers, you can see the contour lines, you can see the mountain, you can see the sea. But basically, what it's showing you is basically the earth or a part of the earth. And that information that you can extract from these entities, from the rivers, from the mountains, from the sea, all of those entities are very important. And critically knowing and understanding this phenomenon and how they are distributed in space are very important. Now, when we come down to this talk for today, I'll mainly focus on how GIS has been used and is still being used in forestry, in human-wildlife interactions. I don't want to call it human-wildlife conflict because people over the years have said that there's this huge implication of saying it's a conflict when in actual fact it's not a conflict, but it's how these two are interacting, humans and wildlife, or humans and or livestock and so forth. So today I'll be talking about mainly forestry, human wildlife interactions, and wildlife management, and how GIS has been pivotal in these areas, in trying to unlock these areas or trying to help us understand phenomena within these respective fields. So this is based on some of the work that I've published and some of the work that we've done or we're still doing, and also some of the work that is out there. And you're free to what to go online and search about some of these things I'll be talking about today. So the first thing I would like to talk about is probably around forestry. Say that there's been increasing use of technology around tree height measurement. And this is an infographic that shows that one of the common or most important variables when we talk about forestry is the tree height. Because the tree height allows us to estimate, it is an important variable that is used in carbon estimation, in above ground biomass estimation, and a whole lot of other parameters that we can derive from tree height if we use allometric measures that include tree height. So tree height is a very critical component when it comes to forest management. And it's also directly related to the carbon that is stored within a tree species. So technology has evolved, and one way that GIS and remote sensing have been able to use or to have been able to be used in this area of forestry include the use of terrestrial lidar systems or the use of a JEDI, an airborne or satellite-borne LiDAR system. For some of you who don't know, this was recently launched, I think it's now 2 or 3 years old by NASA, and it flies and it allows you to get tree height measurements from LiDAR data. So meaning that if the satellite flies over an area that is forested, then it sends, so the basic principle is that it sends beams. Those beams, they are calculated, they are 10 times, and from the first beam that hits the surface of the tree, and then the last beam that hits the base of the tree. So those beams are then calculated and then used to calculate the tree height of any tree species. As you can see, for example, right now, you can see that in this case we have this sensor platform that is sending out beams, and these beams, we have the first beam and then we have the last beam, and these are very important because we can simply then say that the difference between this and this is the tree height. So, but we can also have terrestrial lidar systems. These are the ones where we mount them on land, and then the same process actually happens where you can actually send out beams, and then these beams you calculate the return time for the beam. So these ones are good because they give us a 3D structure. So meaning that you get the top of the canopy, the structure of the canopy, as well as the trunk and any other attributes that you'd want. So this is one key component that has changed the way things are done. Because back in the days, people used to do field measurements. I can imagine if you have an eucalyptus tree and you have to measure the height of a eucalyptus tree, right? It was quite difficult, and then there was error because of the shadow and the time of measurements and stuff like that. So, but with the advent of LiDAR systems that are part of Earth observation technologies, or GIS and most technologies, it has been easy for us to actually measure sea height when it comes to forest-related issues. And then also another important component is wildfire mapping. So wildfire mapping is are very important when it comes to forest because fires are constantly burning, and especially when there is a change from one season to the next. So where I am right now, I'm in South Africa in Cape Town, and there's going to be a change in seasons from the winter season to a summer season. And in most areas, you see that the vegetation becomes highly flammable because our summers are mostly dry, meaning that because they are dry, it means that they become highly flammable and highly susceptible to wildfires. So in this study that we did with Fiona in 2020, we were trying to look at how we can use GIS and remote sensing to map fires. So you can see that these are two study areas that we had, study area one, study area two, and we're also comparing sensors. We were using Sentinel-2 and then Landsat-8, which are sensors that have been commonly used over the past years. And what we're doing here was to say that which sensor would give us the best result when it comes to estimating fires that have happened in our study areas, in study area one and study area two. And you can see that one of the sensors, like this one, was overestimating a lot. This one was better because as much as some of the areas were left out like this part, but most of the areas that were bent were actually detected. So meaning that it becomes easy for us then to use GIS and remote sensing technologies to measure areas that have been bent by fires. And these methods are cost effective because you don't use a lot of money. You simply use your indices, or you simply use your machine learning algorithms, your AI algorithms that you generate, be it they're deep learning or they're not deep learning, or whichever algorithms you use, and then with your satellite data, it then becomes easy for you to then map these wildfires. And then a recent study that just came out probably 2 years ago, we were looking at mapping the land use in South Africa. So we're looking at South Africa as a whole, and we're asking questions to say that where are the forested areas, where are the shrublands, where are the grasslands, and all the other land cover types that exist in the country. And then what we did then was to try and use a random forest algorithm to try and list all the areas in South Africa that have different land cover types. We did this with a very good accuracy, and our paper was accepted. It's actually online and published in a very good GIS and processing journal. I think the impact factor is way above 11, and this just shows you the impact that GIS and remote sensing has in allowing us to understand land use mapping. This work that we did for land use mapping, we did it in the course of probably 6 months. But if we had done or we had used field methods to try and understand these land cover types in South Africa, this would have taken us probably 5 years to move up and down the whole country to be able to understand the land cover types. We're able to do that in 6 months because of the power of GIS and understanding where things are, because knowing where things are is important. Because now we have this information, it means that policymakers can now devise policies that are suited to each and every land cover type. So when it comes to even environmental impact assessments, we now know the land cover type that exists. When it comes to impact assessments, we know what exactly exists in an area. For example, we now know that for example, if someone were to do a project, we then know that in this area it's a forested area, not merely saying that it's a forested area, no, but the evidence exists, the evidence is there to show that this area is forested from the land cover maps that we produced. And another study that we did with Tawanda Gara was to estimate the carbon stocks that exist in one of the forests in, I think it's in Zimbabwe. We're trying to understand, because carbon is a key component and a key entity that people are slowly moving towards, especially when it comes to utilizing wildlife and wildlife economies. And how we utilized GIS was we tried to use satellite remote sensing and to integrate it with algorithms and then estimate the above ground biomass of particular of the area that or area of interest. And then in that area, we then estimated the carbon because we know that carbon is directly related to um, to above ground biomass. So it allowed us then to estimate carbon stocks within our area with an accuracy of probably root mean square of 0.05 or something, which is very important because if we were to use field measurements to go into the field, into this study area and measure each and every tree to measure how much carbon stocks each tree has, this would have taken us forever again. But because of this advent in technology and GIS and remote sensing, now it becomes easy for us to estimate these carbon stocks and carbon stocks, which become important for carbon credits, meaning that in projects where you need to estimate carbon credits, the GIS becomes handy because you can do it with high accuracy, meaning that even if the people in this area decide to say that we want to start carbon related projects within this area, it becomes easy because there is a baseline to start from. The baseline is the data that is produced by GIS and remote sensing. And in another study also, now we're moving to human-wildlife coexistence, we looked at areas that were affected by human-wildlife interaction. And we were looking at this area to say that given an area that there is a protected area, which is Matiti Safari area, this is in the northern parts of Zimbabwe, along the borders of the protected area where it borders with communal areas, we were trying to understand to say which areas are we likely to find carnivore conflicts or carnivore and livestock interactions. And we did this and we understood this better by using GIS and remote sensing. Because if we simply used points, say that this happened at this house, this happened at this house, we would have simply had a map with the dots, but we would not know now what these dots translate to. Because the power of GIS and remote sensing satellite data, NDVI, normalized different vegetative indices, which are indices that we can use to understand the vegetation, because of understanding the distance to water, the distance to settlements, and all those other metrics and variables that you can measure within a GIS system, we're able now to present a human carnivore conflict or a human carnivore or livestock carnivore interaction or coexistence map that shows the risk across the landscape. To say that if someone is settled within these areas, the risk is very high. Someone is settled outside of these areas, the risk is very low. So this was something that was also important and something that we did. Why we did this was because we wanted to solve a problem. So remember, GIS is not a technology that is just there to exist, but it's a technology that is there to solve a problem. And one of the problems that we wanted to solve in this case was to say that how can we reduce human wildlife interactions and at least enhance the coexistence of these two entities, humans and wildlife. And one of the key things to understand to say that, okay, where are the conflict areas or where are the interactions happening where those interactions would lead to uh, livestock depredation. So this was the first step that we did to trying to understand how humans and wildlife interact. And it was very essential for us to use GIS and remote sensing. Like I said earlier on, we would not have created this risk map from the points of where this incident had happened, but we had to utilize the capabilities of GIS and remote sensing to now understand the broader picture within the across the landscape to say that this is what will happen. So these are the areas that are that have high risk or risk-free when it comes to the interaction of the two. And another paper again, we also looked at animal movement within national parks, and we're also looking at animal movement outside of national parks. This was in Kenya, in the Amboseli ecosystem, and we're looking at elephants and how these elephants move. This was the paper we did with Gara. It was published, I think, 2 or 3 years ago, and then Tawanda again, Tawanda Gara. And what we're looking at elephants to say that, okay, elephants move in these areas, and these areas are the areas where the probability of occurrence for elephants is very high. And as you can see from the maps presented, the probability, the occurrence was quite high within the national park or the protected areas. Interestingly, you will see that there is a high probability of occurrences that are outside or on the borders of the national park, which becomes concerning for all the communities that will be residing along these areas. So then it was important for us to try and understand the dynamics of elephants movement, because once we understand these dynamics of elephant movements, it becomes easy for us to use telemetry data, that is your GPS fixes for each and every movement that it would have been done by the elephant, and then try and convert this into a heat map like this one, and also to identify the corridors. By corridors, we're now talking about areas we feel like are important in the movement of elephants from one habitat to the other. Those areas that connect the two, and then we're able to map the corridors and say that these are corridors that connect the two, and they're important. And you would see that if we were to propose in our publication, one of the things was to say that settlements should not be in these corridors because these are important for the movement of elephants. So even any development should not be within these areas because these areas are important for elephant movement from one habitat to the other. So meaning they connect elephant habitats. And then we also looked at another study. I mean, when you want to really understand these elephant movements, we also want to understand it from a point to say that what drives movement, right? What drives movement in species? And we're looking at elephants, and we were trying to answer the question to say that what drives elephant movement in northwestern Zimbabwe, and we're looking at Chizarira, Chirisa, and all those other areas, trying to understand that there are elephants in these areas, but what drives that movement? So we did that, and then we ended up having this map that shows elephant presence and the predictions that we made to say that, okay, these are the areas where elephants move from, and these are areas where elephants are likely to be. And we had a very good hypothesis, and the hypothesis was premised on the fact that human settlements are the key drivers of elephant movements within this landscape, because you will see that in all these areas outside of the national park, you will see that that's where elephant presence is very high, but areas outside of the park, elephant presence is very low, meaning that humans were confining elephants within national parks because this became a safe haven. This becomes safe havens for elephants as compared to areas that are outside of national parks. This could be good, but now the problem is that this was detrimental because elephants need that connectivity to move from one national park to the other, and to move from, like we see, from Chizarira to Chirisa, to be able to move from one area to the other, because of elephants as you know, they're huge in size, and it means that in terms of their dietary requirements, they might not be sustained within one area, and that movement is what is important. So we then went on to try and understand what are the drivers of these movements in elephants. And then I think this will be the last one. We also looked at elephant mortality and climate change. This paper me and my colleague are writing, we're looking at what what how can GIS and processing help us understand the effect of climate change and elephant mortality. In this case, we're looking at the current climate scenario and the future climate scenario. And we're looking at, this is the same, this is the Wangi National Park, and this is the current, the top is the current, and then this is the future. But here we have a probabilistic function where we're saying that the probability is moving from 0 to 1. And then in this case, we have a binary where it's 1 and 0 to say that the areas that have high probability are here, and then the areas that have low probability are the white areas. So we're trying to understand elephant mortality and climate change. And this would not have been possible without the use of GIS and remote sensing. So you can see that clearly when it comes to monitoring and understanding wildlife and wildlife management and forestry, it becomes important to utilize these technologies, GIS and remote sensing, because they are vital as understanding our landscapes beyond just what we know or beyond the eye, right? So we're just going to quickly look back at what I spoke about. And I think at this point, I want to take questions and also open the floor to reflective questions that could probably just start the discussion and questions that you guys might have. And probably just one of the things that we can reflect upon if there are no questions is say, have you personal experience in unexpected challenges or breakthroughs in your work with GIS and remote sensing and so forth. So we're just going to try to reflect on those things, and please feel free to ask any questions if you have any questions, or if you have anything that you feel like needs to be explained more, please feel free.
Okay, thank you, sir. I do have two questions from here, according to what you have presented. The first question goes that what's the difference between GPS and GIS and the uses of GPS? But also, you have spoken on the issues of carbon. How could we harvest carbon in our forests that we have around us, maybe, or in forest areas?
Yeah, thanks, Alex, for that question. So the difference between GPS and GIS is that GIS is like I'm going to loosely give an example here, so please don't misconstrue me. GIS is like the kitchen, right? And GPS is like the pot, right? So, I mean, you can be in a kitchen and you might not need to use the pot. You can use the pan and you can use the microwave. You can use the plate. You don't need to use the pot every time. But it is important to have a pot that helps with every function that pertains to the kitchen. So a GPS is an instrument or a device that allows us to capture location on Earth. So remember when we're talking about X and Y, when we're talking about geographic information earlier on, we said that geographic information is information that is in X and Y. So a GPS allows us to get that X and Y. So that X and Y is what is important for us to then use that data in a GIS. Because a GIS is a system, right? And then a GPS is a tool or a device that allows us to use the system. But above all of this, above the system and the tool, we have the science, right? The science is now knowing what to do at what point, right? If I give you data right now and say that, if you, for example, I give you, if you look at an elephant or moving back and forth, and then I mean, someone could say that this elephant is just moving, but a biologist could say that this elephant is moving because of this, or this elephant is moving in this direction because of this, which becomes that is the science behind the elephant movement, right? So here we have the science, that is the GIS science, and then we move a level down, we have the GIS system. The GIS systems are those applications that you have, your ArcMap, your QGIS. If you're using online platforms, you have the Google Earth Engine. If you're also using other platforms, you have like your Microsoft Planetary Computer, you have your Google Earth Pro. Those are systems, GIS systems, and those systems rely on the use of a GPS to give us locations. So you see that a satellite image that has the wrong locations it will not be useful. That's why you see that even when a satellite is launched, it is very important that it has a GPS system on the satellite so that it is able to locate things correctly. That's why you also see that cars now are also having GPS devices because they are important tools that allow us to get location on Earth. So a GPS is an important tool that feeds into the broader system. So that was one of the first technologies that was brought about or invented in terms of GIS, because it allowed us to understand more, right? So we had this GPS, and then slowly people moved to the system. And it's a very important tool. That's why I likened it to what? To a pot. I mean, you can do without, but it is always important to have a pot in your kitchen. And then the other question is about how can we harvest carbon. So the thing is that carbon, ideally, we don't want to harvest it, right? Because of climate change and everything that is happening, and the effect that it will have if we harvest our carbon. So ideally, we don't want to harvest carbon, but what we want to do is to store it and use it, like especially in Africa, right? In Africa, there's this huge potential that we have. Look at, I'm not so sure where you are, but look at DRC, it is forest, Uganda, Rwanda, Burundi, all those areas, they have these huge forests that are there. If you also move down to Kenya, you move down to savanna ecosystems, there are these huge forests that are there. We can monetize those forests. We can only monetize them if we maintain the carbon that is within the trees. So by maintaining that carbon in the trees, we then use those trees to buy what we call carbon credits. So basically, I'm sure you know what carbon credits are. We are saying that someone in elsewhere, probably in Australia or the UK, is saying that, oh, we are polluting the environment, and we want to rectify this by preserving an area somewhere else that is intact biodiversity or intact carbon stocks. So then you have your probably your area in Kenya or Naivasha, or whichever area that you have, and then you say we're going to maintain this area and not cut it down. The trees are going to be maintained so that they can store the carbon, and we can get money, right? So the communities around those areas then benefit from that money, and so forth and so forth and so forth. So ideally, carbon, when it comes to that, we don't want to harvest the carbon. We want to make sure that the carbon remains in the trees as carbon stocks, so that we can monetize the carbon. I don't know if I answered your question correctly. Yeah, thanks, Alex.
You've answered it well, but also I have some of the questions that follows. We
Yes.
do have, I'm in Tanzania at the moment, but we are still having the issues of wildlife conflict currently. Especially, people are still building up houses and establishing the settlements around out wildlife corridors, but also in wildlife in WMWs, but also in wildlife buffer zones. But I don't get a real idea what is this. What are these people doing actually? Can you help me a little bit?
So, Alex, the question you're asking is a very complex one, right? But one thing that you and me have to agree on is that land is an important entity or asset that you and me fund, right? So because the land is important, and when we look at the hierarchy of organisms, we humans, we believe we are at the top, right? So because we are at the top, animals, probably at the second or third, are not important when you look at them from that perspective, right? Which is not a holistic perspective, right? We are saying that we humans are at the top, and then animals are below us, they are not important. So we should do as we please, right? So that's where we end up having those issues where people then start killing animals, people start destroying the environment because they say that we don't care because we are above everything. But what we need to change, or what we need to enforce, is a holistic perspective to say that, yes, it is important for people to build. Because like right now, we're sitting in a building. If that building was not there, life would have been very difficult. But how can we develop sustainably in such a way that our resources or the environment is not damaged, but it is maintained? So one of the key things that we are facing, or we should address, is to say that how can we sustainably utilize the resources that we have? So, for example, we can talk of hunting. You look at a country like Kenya. Kenya has always said that they don't like hunting, and hunting is not allowed. But hunting, if done sustainably, it can improve the lives of people and communities, right? And this is a huge debate that is ongoing in the UK Parliament. So basically, what I'm trying to say is that we need to do things sustainably because development is important, economic development is important, but how can we do it in a sustainable way where we do not destroy the environment around us? Because this is all based on the future. We need to make sure that we are aligned to our future needs. I hope I answered that one correctly. Thanks, Alex. Maybe we can start reflecting on these questions to say that how have you personally experienced any how have you personally experienced any unexpected challenges of let me check in the chat before. Okay, good. Yes, please, Walter, feel free. Walter, please feel free. Okay, so whilst we wait for Walter to type his question, maybe we can just simply reflect. I mean the people who are on the call, we can quickly reflect if you have experienced any unexpected challenges or breakthroughs in your work with GIS remote sensing. Can you provide examples of useful wildlife conservation projects that have utilized GIS remote sensing? And what are the future trends, or what you think are the future trends and innovations in GIS and remote sensing that could revolutionize wildlife monitoring and conservation? So, I mean, if anyone wants to reflect on that, that would be quite interesting so that everyone else can benefit from that. So please feel free to, once Walter is done, please feel free to answer any of those questions. Yeah, thanks for that question, Walter, that you asked in terms of what are these. Walter is asking that other than GIS, we also have biological indicators like birds and animals' presence in an area. What are these animals and birds when it comes to ecological monitoring? I think you've clearly said it, Walter, in your question to say that these are indicators, right? They are birds and animals are important indicators that talk to the biodiversity of an area, right? So the more these are, like we're talking about, the more birds from a diversity perspective. If, say, for example, in an area, I'm going to try and maybe scale this down so that probably you can understand. So try to think of this at your uh, in an area that you stay or in your neighborhood or in your communal area or wherever or in an area that you work in, and try to think of um of that area before it was what it was today. Before it was what it was today, I'm thinking that it had a lot of trees, there's a lot of animals, a lot of ants, birds, snakes, elephants, you name it. All those species were available. But with time, you will see that those species continually increase, meaning that these species become important because they become indicators of ecosystem health. They become indicators of how pristine an environment is. So understanding the diversity and the number of species is also important. And GIS can actually help us through systematic and well-planned aerial surveys. We can have systematic and well-planned aerial surveys that can allow us to understand the location of these species and the density of this species and the diversity of this species in a landscape. At the moment we understand the location, the distribution, the density, and the diversity of this species in a landscape, these become, over time, they become indicators to say that in point A, we had 10 elephants. At point 2, we have 10 elephants plus 3 birds. At point C, we had elephants, birds, this and this and this, meaning that we would then assume that the diversity is increasing, so the ecosystem is healthy. But the moment we move towards one species, or the moment one species declines more, it becomes a problem because now we we assume that the ecosystem health in that area has been compromised. I don't know if I answered your question very well, Walter, but it's these, like you said, like I said earlier on when you asked, these are indicators, and GIS can come in and show us where these are distributed, and then it becomes easy for us to understand the ecosystem health within an area.
Kudzai, if I may just tell a little story here. We received a lecture last year from Dr. Michelle Henley, who's an elephant expert in the northern parts of the Kruger National Park. And she tracks elephants, specifically male elephants, to look at their movements. And it's related to what you just mentioned. The way that elephants change their behavior and their temporal movement when they leave the Kruger National Park into Mozambique, where they are unprotected. It's very interesting to see how the elephants actually stop moving in the daylight and only make very tentative, careful movements, whereas the moment they step over the border in the Kruger National Park, they start moving around freely again. So it was just interesting how this movement and geographical information is actually an indication of wildlife security. You can just see what the elephants are doing, and it's very, very interesting. So GIS is also a very important tool to make sense of that kind of data.
Thanks a lot, Johan, for that. Yeah, it's very true because, like, you see, once we have these maps, like the one that I'm showing, it becomes easy for us to visualize these things. Because someone can say that this is a lie. Once we have these maps, this becomes our evidence. Because we have GIS, we must say that this is where the elephants are, and these are the areas they're utilizing. And if you like what you're saying, the temporal period to say that over time during the day, this is the time or the movements that are done. And then at night, these are the movements that are done, which becomes easier. Yeah, thank you for that contribution, Johan. Is there anyone else with a question? If there are no questions, I think from my side, I am done. Over to you, Johan, or Prudence, or Marit.
Kudzai, from my side, I would just like to thank you for your time. It was a super interesting introduction, and this is what it was. It was the introduction and the reflection on the use of GIS in so many different situations, and it really just makes one enthusiastic about it again. You want to go and brush off your skills and know that you can use this in so many places. And it's also interesting to me how you are an expert in both ecology and GIS, and how that makes you see things in a different way and in a very interesting way. So I just want to also encourage the students to use both the knowledge of technology as well as ecology to solve problems.
Yeah, thanks, Johan. I've put in my details in the chat box. If anyone wants to reach out, please feel free. And we can always discuss more when it comes to these aspects, or if they have anything dissertation thesis that they're working on that they need help with, please feel free to reach out. And you can do it through Marriott, you can come to me directly. I don't mind, but please feel free, and I'm always available to help.
That is a absolutely fantastic offer, and thank you so much for it. Students, I would encourage you to make use of that. So I think if there are no other questions, we're going to thank Kudzai, and we look forward to meeting with the students again. See, there are a lot of expressions of gratitude. Kudzai, thank you so much. And then we will see each other again soon in another lecture.
Thank you, Jan. Thank you, everyone, for joining.